Hi, everyone, and welcome to today's Rancher Meetup. I'm Shannon Williams, and I am coming to you live today from Amazon reInvent here in Las Vegas. And really excited to see so many people on today's meetup. It looks like we're going to have a record turnout. I thought last month was going to be the record, but it won't stand for long. Looks like we had more than 3,000 people register for today's meetup. So welcome from all over the world, wherever you're coming from. I am joined today by my co-founder, Darren Shepard, here at Rancher. Hey, Darren, how's it going?
Great. Excited to be here.
Yeah?
Yeah.
You've made your sacrifices to the demo gods, and we're ready for another amazing meetup?
Yep.
Darren's coming to us from Arizona, and Darren's the chief architect here at Rancher. I'm the run our sales and all of our community stuff, and it's great to have so many of you on today with us. We have a packed agenda. We're going to be talking a lot today about Kubernetes deployments inside of the new Rancher 2.0 and sort of the direction we're taking our new RKE project that we announced yesterday. And in the meantime, though, just a couple housekeeping things. If you've never attended a Rancher meetup before, these are pretty different events from your typical company webinar. It really is a meetup. We approach this with the goal of getting people involved, getting you to know each other. We run them every month, or pretty darn close to every month. This is probably our 30th meetup since we started these back in 2015. So thanks for getting involved and joining. Since it's a meetup, a couple things that you may not be ready for. We don't have a concept of time on these things. We try to go quickly and get as much content in. I know a lot of people have an hour to spend with us, which we try to get as much as we can in that first hour, but we don't bother with an end time. We're going to stick around as long as you want to ask questions. So ask them. Questions are welcome at any time. We don't sort of say hold all your questions to the end. We might be rolling on something and kind of pause on questions for a few minutes, but by and large, it's meant to be an open discussion. So as we move through, we'll have a couple different topics. At any point, if you have a question, the way to ask the questions is, unfortunately, we're not in a big meeting room together, so you can't just raise your hand and ask, but put a question into the question bar in the GoToMeeting app, and I will respond to it. If it's a real kind of obvious question, I might just respond in text. Otherwise, I'll probably, when Darren hits a reasonable stop or I hit a reasonable stop, one of us will stop the other one and sort of just ask the question out loud. We may also respond to everyone. So sometimes a question, just as a simple answer, I might just type out the response, but I'll send it to the whole audience. So your question might be seen by everyone. So if you have a private question, you really don't want anyone to see it, just put private or something, and I'll be sure not to respond out. So no bad questions. We have people that have been using containers and Docker and Rancher and Kubernetes and stuff for years, and we have people who are just getting started. Don't stress. Just ask your questions. We'll answer them really quickly. The other thing is it's all live. We're demoing. We don't do recordings. Things occasionally break. Be patient. We try to have backups, sort of, the souffle sitting in the oven that we can pull out in case networks go down or our code breaks and our bugs explode. So be patient. And if we do get some problems, we'll always be telling you what's going on as it happens. So thanks so much. The one thing we do to kind of try and get to know each other is we use Twitter a lot during the meetup, and I really invite you all to introduce yourself if you're new, or say hi again if you're joining us again. We use the hashtag Rancher Meetup. If you post a picture, and the first 10 who post a picture, I've got some really cool Rancher trucker hats that I'll stick one in the mail for you. So post your picture, say hello, tell us where you're at, what you're doing, and maybe how many of these you've attended, anything you want to share. But also feel free as we're going to chat in that hashtag, about what you're hearing, what you like, what you don't like, other projects that you think are interesting, or anything else you think might be interesting to the group. It's unmoderated, unfiltered. It's for everyone to just chat. So today's agenda, I'm going to give a quick update on Rancher 2.0. For those of you who didn't attend last month's overview of it, I'll just kind of really briefly recap that and point you to the recording for last month's meetup where we really introduced it in some detail. Then Darren is going to dive into Rancher Kubernetes Engine, and he'll talk about this new project we announced yesterday. It's sort of a new way of deploying, installing, and bringing up Kubernetes clusters. We'll demo it. We'll kind of show you how to deploy it, how it works. Then we'll give an update on Tech Preview 2, which is the next release of the 2.0. It's coming out in the next few weeks. and Darren will show you some of that, how things like RBAC and cluster management are working, show off a little bit of the new workload management stuff that's in there, and we'll wrap it up with any remaining questions. I'll show you how to get started if you don't know where to find all the docs and all the GitHub projects and how to spring up a Rancher environment for some testing in your lab. So a lot to cover. We'll be moving as quickly as possible. But today, we really wanted to do a meetup before we release the next tech preview to talk about sort of some of the changes we're making in how we build and manage Kubernetes clusters in 2.0. I mean, Rancher has been running production Kubernetes for 2+ years as people have been using Rancher. We've supported Kubernetes for a long time. It's incredibly popular among our 15,000 organizations that use Rancher to manage their containers. But in 2.0, we really are putting Kubernetes central to the orchestration. So if you've used Rancher 1.0 or 1.6, Kubernetes was one of the orchestrators you could choose from, and really. We walked through this last month when we introduced it, but with 2.0, we are really we're going to standardize the orchestration components around Kubernetes and make that the core orchestration system that deploys our deploys containers. What we're really focused on though is sort of taking and bringing all the things people really love about some of the other orchestrators, Cattle and Swarm and Mesos and other things we do in Rancher 1.0 and making that really easy for people to move to Kubernetes. So we demoed this last month. We showed how you just can take existing compose files and Cattle environments and simply deploy and run them right on Kubernetes without changing anything. And people were really excited. But with 1.x, we really are moving from being sort of built on Kubernetes or built on Docker where Kubernetes was one way of approaching things to now having Kubernetes as a consistent standard orchestration layer across all different use cases and extending around that with a whole bunch of the things that our users love around managing their environments, managing clusters. So if you think about the new functionality that we're developing and what we're adding to 2.0, it's really there's really kind of three layers. One is we're continuing to provide a world-class Kubernetes distribution, and that's a lot what we're talking about today with RKE, deploying Kubernetes, managing it, upgrading it, all the things we do around the lifecycle management of Kubernetes on any infrastructure. But we do a lot more than just that. We also provide sort of unified cluster management that means we manage Kubernetes clusters deployed anywhere, whether it was stood up by Rancher and upgraded and managed by Rancher, or it was hosted. It came from Google or Amazon, or you have a team that's already got Kubernetes running. You simply deploy a couple containers and Rancher will start managing that, and managing that means all of the kind of policy and RBAC and UI and workload management that people really love about Rancher is applicable to really any cluster, whether we deploy it or not. So we'll be dealing with this concept a lot as we go through about how we've moved the Rancher Cattle experience, which so many people use, onto Kubernetes. We'll be talking about importing and managing Kubernetes clusters as we go. And really, today, a lot of the stuff we're going to show is actually this RBAC policy management things that we've extended in 2.0. If you think of Rancher 2.0, in fact, I'd really say it has three key layers that make up the stack. At the lowest layer, we have Rancher Kubernetes Engine, which is how you can very easily stand up a Kubernetes cluster, either just by leveraging RKE or using RKE as part of Rancher. We expect most of that's going to be being deployed on bare metal, vSphere, maybe clouds that don't offer Kubernetes as a service. For clouds that do, Amazon just launched yesterday at reInvent a new service called EKS, which is their Kubernetes service. Google, IBM, Microsoft all offer Kubernetes as a service today, and so what we sort of see happening. We talked about this a lot last month. Is that more and more cloud providers are going to offer you a Kubernetes endpoint if you want to use Kubernetes and manage container clusters. Those things are going to be a little different. So as you move from cloud to cloud, the reason you might use EKS instead of standing up your own Kubernetes cluster on Amazon is that it should be really well integrated into Amazon services. So it'll work well with ELB. It'll work well with EBS. It'll sort of work well with the existing Amazon services, and it'll work into all your IAM. You'll be able to understand how to bring up a cluster very easily in the Amazon And if you're in Google, that'll be different, right? You'll have different approaches to storage and networking. You'll have some different capabilities. So there's not necessarily going to be identical in terms of how they interface with the infrastructure and expose different infrastructure services. But as far as Rancher is concerned, we'll be able to take those as well as any Kubernetes we deploy anywhere, and all of these will fall into our unified cluster management. So as an organization, you can provision any of these things, you can scale them, you can manage the upgrade of the clusters and how they sort of go through the life cycle of moving from version to version of Kubernetes. And you'll be able to configure and deploy RBAC policies, security policies, all sorts of things about what it means for someone inside of your team to consume resources out of a Kubernetes cluster. We'll deal with all of things like capacity management and even cost management, usage monitoring against all these clusters. So we call that sort of cluster management, and it's the goal here is for the ops teams that are responsible for running all of these different clusters now in potentially different clouds around the world on premise, and to make it really simple to manage these, ensure that you have identity management across everything and single sign-on regardless of where you're at. And then the other layer of what we do is we call it workload management, but it's really everything that takes that Kubernetes kernel and turns it into a platform that you want to use to run your applications. And part of that is all the user interface for deploying and managing your Kubernetes deployments and your container environments. I think we've got a really long experience with Rancher of how to make that easy and simple for people to consume. It's the app catalogs, it's the sort of integration of services like Prometheus and Elk Stacks for logging, and just all of the elements that go to the actual operation of a workload using containers in a consistent way, regardless of which engine is running it in the background. So that's really Rancher. With 2.0, as always, it's open source software, very easy to deploy, set up, and get going with, and really takes everything from an ease of use that people love about Rancher and extends that to sort of run on any cluster anywhere. So today we're going to introduce RKE, which is that bottom layer I talked about. It's a new Kubernetes installer. It's Darren's going to talk about it. Darren, you want to share your screen and you can sort of dive through these slides a little bit?
Sure.
Let me make you the presenter.
Let's see. All right. You should be seeing my screen now, right?
Yep, you're presenting.
All right. So yeah, so today we're excited to announce the Rancher Kubernetes engine, short is RKE. And so basically, as Shannon and I talked about before, what we were doing in Rancher 1.6 was we were deploying and managing a Kubernetes distribution. So what we had demoed in Rancher 2.0 was specifically what we've already demoed with the Tech Preview 1 that we put out in 2.0 is importing existing clusters, because we do believe that there's going to be various different ways to get Kubernetes, and a lot of people are going to be getting Kubernetes from the cloud provider, and that's what Shannon was showing on the previous slide. Of there's Amazon has a service now, Google has a service, Azure has a service. I mean, all the major cloud providers, and I imagine that will continue. That most infrastructure providers are going to continue to give you Kubernetes, and so we believe in that approach. We think that's something we definitely want to support. But right now there are still gaps, namely in bare metal and like a vSphere deployment on premise, where people don't have Kubernetes available. So even though we do see the future of that you're going to be able to get Kubernetes from various different places, there still is a very immediate need that people need a supported Kubernetes distribution. And so what Rancher Kubernetes Engine is really that supported distribution from Rancher. I mean, honestly, we don't try to say it's the best or better. I mean, we really look at it as Kubernetes is a commodity. It's the bottom layer. It's the common thing that you can get from everywhere. So what we're giving you is Kubernetes. It's a certified CNCF distribution. It's the same thing we have in 1.6. but we brought that over to 2.0. But we've taken a slightly different approach on how we're doing this, in that it is not actually, while it will be bundled into Rancher, the complete Rancher management platform, it is also available as a simple standalone CLI, because we think that opens it up for a lot more use cases and a lot more flexibility. So it's very simple to run, it's very fast, and it works anywhere. So again, one of the key things for us is we wanted to provide a simple portable Kubernetes deployment, not something that's going to be super well integrated into the infrastructure, because in those situations, you're most likely going to want to just get it from, like if you want something super integrated into Amazon, then getting it from Amazon might be your best approach. Or there's some other tools that might give you that. So what we wanted to do was provide a simple portable one that's just, it's going to work anywhere. So for this, we originally we had hoped to leverage an existing tool. So we started with KOps and Kubespray. Those seem to be like the two most popular ones that we found, and looking to see if we can just use those instead of kind of building our own thing. And we found that while these are great tools, they fit a slightly different use case. So KOps, for example, is excellent. It's really, really well done. It works great on Amazon, and it gives you a really well integrated Kubernetes deployment on Amazon. But it doesn't support other clouds quite yet. They're still trying. They're kind of trying to port that over. But the approach of basically making it well integrated with the kind of the environment, whether or not it's Google or vSphere or whatever, is not exactly what we were looking for. Again, we were just basically looking for a portable one, something that's most likely gonna that works well for bare metal and vSphere. So the other approach that we looked at was Kubespray, which is based on Ansible. And again, Kubespray is also very good, and they take kind of the more portable approach of like, this is going to run anywhere. I think that basically the only kind of major complaints we have with that is, one is it's quite slow, but it was more just the approach of using Ansible, is that it's looking at pretty much configuring also the operating system, setting up users, setting up like systemd things, and basically our kind of concern with that, it was a little too intrusive on the hosts. And so as we look at things, we really want, we're very concerned about like enterprise and making sure that whatever we're doing is going to work within any environment given whatever requirements you have and whatnot. And the approach that we've taken in the past with Kubernetes in Rancher 1.6 is we packaged everything as Docker containers, and all we required on the host was Docker. That worked very well. We didn't get much pushback from people. Like, we don't really touch the host much. We don't do anything. And so with the Ansible-based approach, we felt it was doing a little bit too much. And so we ended up just basically going back to, let's just do what we're doing in 1.6, but just make that standalone. And it actually ends up working out really well, because one of the things that with Kubernetes is it's getting easier and easier to install, because Kubernetes itself is like a highly available self-healing system to a certain degree. So in Rancher 1.6, we actually used our cattle orchestration engine to deploy Kubernetes, and then like if something goes down, we delete the container and we spin it up somewhere else. And basically all of that additional orchestration that we were adding is really not needed so much anymore, because Kubernetes itself is basically taking care of doing those things. So when you look at the deployment of Kubernetes, it's getting significantly easier, and it's a lot more static. And so pretty much all you really need to guarantee is, okay, I've deployed these components and they need to be running. So I need some type of supervisor. Like that's what like systemd would do, is like make sure the process is running. Well, for us, we just use Docker. So okay, we ensure that Docker, Docker will ensure that the containers are running. So really the way RKE works is there's no master orchestrator or anything of managing the Kubernetes deployment. All we do is you run the CLI, and I'll demo this all in a little bit, is you run the CLI, which goes and it talks to each individual host and deploys Docker containers that have Kubernetes in it. And then once those are running, basically Kubernetes manages itself to a certain degree. So you look at like etcd. Etcd is a highly available system. We set up 3 etcd servers. Those servers, if one of them goes down, well, if one of those goes down, the other 2 are still functioning. It's like it's highly available in itself. The same thing with the control plane. If like we launch multiple servers, the Kubernetes control plane components, they do leader elections. If one goes down, the other one will take over. So basically, Kubernetes is going to make sure that it manages, that it's highly available, that it's up and running. The only thing that's not going to happen is you're not going to get automatic recovery. And that's where, that's where if you plug into something like Rancher or Container Manager, which then gives you more visibility of what's going on in the cluster, or you plug into a different monitoring system like Sysdig or Datadog or something like that, then they can help you with kind of the monitoring when a component fails to then end up recovered, but the system is still highly available. One of the other things that I kind of forgot to mention of why we ended up creating RKE was we really wanted to make sure that we have a production-ready HA deployment. Some of the tools out there it's a great idea. For example, like kubeadm, we'd love to be able to leverage kubeadm, but right now it still doesn't do HA. So we took a lot of the concepts and what kubeadm was doing and put those into RKE. Okay, so I think and the last point is it's very easy to extend with add-ons here, and oops, there we go. I'll talk about the add-ons a little bit more. So RKE, it's just very simple. It's a command line utility. It just takes a single file, which just describes pretty much what's the authentication you're going to use, what's the networking, what are the nodes, like what's the address, and then what are the services that we're going to deploy. So the nodes, we need an SSH connection. So we SSH into the nodes, but we never actually run any commands directly on the nodes. We just use SSH to basically get to the Docker socket so we can run Docker commands. So we just run the Docker commands and we launch these. Each one of these services is a different Docker container, and it has, oops, sorry, when I clicked there, it went for it. Each one of them is a service, and basically you can configure what the image is, which basically controls what version of Kubernetes you're running. So all you have to do is you create this file, you run up, it will deploy the cluster. If you want to add a node or remove a node or change something, you just edit the file, run up again, and then it will change things. Right now you can scale the control plane and worker nodes, but you can't scale etcd. Right now the etcd cluster is static. That will change, but that's what the functionality is right now. And so the last point, what I was talking about is add-ons, is once you get this cluster, like once you run once you run RKE and you get a cluster up, we then have a very simple hook where you can then just run any arbitrary Kubernetes YAML at the end. So this ends up making it really interesting because we can address different use cases where maybe you are writing an application, like what people are using, starting to do is using Kubernetes as a general orchestration platform. So you can write your own general orchestrator, not necessarily dealing with containers or anything like that. They're just using it as an orchestration platform. You can write your own orchestration code and then bundle this with RKE to then deploy Kubernetes itself plus your orchestration code. So you can just use this as a way of just basically distributing kind of like prepackaged applications in Kubernetes. So there's a lot of other things you can do with it with the add-ons. I mean, just basically, it's just once you get a cluster up, you can then just run any arbitrary Kubernetes YAML, which is then going to start deploying other things.
Hey, Darren, there's a whole bunch of questions before we move on. Do you mind if I just fire off a couple of them to you?
Sure,
I've been answering loads of questions, by the way, guys. Great questions coming in on the chat. Keep I'm trying to respond to them quickly, but there's a couple questions that I think are really relevant to the RKE discussion. One, David Pratt said, did you look at Terraform as a way to stand things up? You want to just talk about that?
Yeah. So basically, we looked at Terraform, and really what it comes down to, kind of one of the difficulties we had with Terraform is really just the state management of Terraform. Is we needed something to be a little kind of, because basically everything has to be managed through, everything has to end up being managed through that Terraform state. So if you go and if we change the cluster behind the scenes, like scale it up, scale it down, or whatever, and that doesn't match the Terraform state, then it won't really reconcile. And so Terraform is a great tool. We use it in a lot of different places, but because of like the rigidness of that model, it ends up becoming too much of a problem for us. And the reason it ends up being when we start plugging in RKE to Rancher, because then we start making it a lot more dynamic, and we never really have like the model of like everybody has to always go through us. Like there's you can kind of go directly to Kubernetes and change things and add nodes and whatnot. And so that's where we kind of ran into the problem with Terraform. So, I think so the thing is like any configuration management tool could do this. And so like that's what Kubespray did it with Ansible. Terraform can do it, Puppet, Chef, all these tools can do it. And we were looking at this and we're like, well, which one do we choose? Because we very much didn't want to build our own thing. But when you look at like the direction of Kubernetes itself, it's not actually that hard to deploy and manage Kubernetes. I mean, it takes a lot of, I guess, knowledge of exactly what are the right flags and whatnot. But at the end of the day, what you're really doing is you're launching a series of binaries with certificates and command line parameters. And the direction of Kubernetes is to make that even easier with like self-hosting and doing all this bootstrap. And so it's just getting simpler and simpler to deploy it. So, while picking up something like Terraform is like a super powerful and amazing tool or whatever, it wasn't really it was almost too powerful, and it does too much. The other thing is we actually really don't need the integration with the cloud parts, because again, we were really focusing on like bare metal, vSphere, those type of deployments, because we don't need to be dynamically spinning up nodes. Like the way we took the approach with RKE is you already have nodes, we're just going to deploy with Kubernetes. So honestly, it was super difficult. We went back and forth quite a bit on what was the right approach. Like because we looked at all these things of Terraform and Kubespray and I think at the end of the day, we just kind of felt that it should be a problem that's simple and should get simpler over time, and so we kind of avoided pulling in a larger framework.
Thanks, Darren. There was another question kind of on the same topic. Federico Hernandez asked how does RKE compare to kubeadm? And now, long run, how is that different?
Yeah, and so I think the thing is with RKE is like I don't think we're necessarily saying. I mean, we saw that there's kind of two things. There's a gap in that. Bare metal and on-premise deployment still need a good solution. The other thing is people want a supported distribution from Rancher for different use cases, and so we needed to fill that. And we very much wanted to use kubeadm. Unfortunately, kubeadm right now does not support HA, and it's still coming along. So what we're doing with RKE, I don't say, as what I was trying to say before, is like it's not like what we're doing we think is the absolute best way, it's the best Kubernetes, or it's way better than any of these other tools. It's like there's a bunch of different ways to basically get Kubernetes, which we view as pretty much a commodity. And so kubeadm, we really hope that kubeadm will continue to enhance and get better, and we can do maybe you just replace RKE with KubeADM eventually. So I mean, we have no kind of like stake in like we want to be competitive or better. It was just really the approach of how they're doing it. They're still working out a lot of things, and so again with RKE, we pretty much. I mean, we really did like the way we set up Kubernetes. It's the same way we do it in 1.6. We just basically wrote a Go program to launch those containers the way we did in 1.6. So it's not like we invented a whole kind of, it's like this is how we were already doing it. We just pulled it forward into a simple CLI.
Yeah, I think that's a great way of putting it. We also broke it out. I mean, the big thing is we just wanted to break it out, make it easy and standardized, and allow you to do these things however you're consuming them. We just anticipate that Kubernetes will get stood up in all sorts of different ways, and that was a question earlier. With Rancher 2.0, you can bring you can use any approach that makes sense for what you're trying to do. This is one available approach. It'll be easy to use if you just, especially when you're dealing with things like bare metal. There are a lot less good approaches, or OpenStack, or VMware that just did not as much as when you're in the cloud. So, John Sims asked if RKE would actually allow you to do deployments that span multiple cloud environments. Do you want to talk about that, Darren?
Yeah. So we don't have any. So RKE itself doesn't impose any additional like architectural limitations or enhancements, I guess. So it's basically we need a series of nodes, and then we'll go and deploy those nodes. So where you're gonna have those nodes deployed is up to you and the requirements of what Kubernetes is. So for example, you're not going to run etcd across 3 different regions because the latency is too high. You can do it across availability zones, but you can't do it across regions within like AWS. You can run so etcd, for example, those need to be close, a very low latency connection. The connection from the control plane to one of the worker nodes is not as latency sensitive. But again, it can't be too slow. So you can actually run those across like cloud providers if you want, but it has to be a good connection. So don't go from China to US or something like that. So the thing is it's definitely feasible, but it's just you're just bound by whatever the limitations of Kubernetes in general, which is you need good connections, always on, and then so we don't really care in terms of for RKE where you pick those. And then we do also have the concept of like an internal address and an external address. So you can set up things on private VPCs and then have the management go over a public VPC and whatnot.
The couple more quick questions there. Maybe we can kind of just get answers quickly so we can dive back in. But so the one is, the question was, can I do everything with the CLI that I can do with YAML files in RKE? Does that make sense?
Well, so the really there's, I mean, for the most part, there's really just one command. It's like there's up and then there's remove, and then everything's just based off of the YAML file. So the CLI doesn't do like add host, remove host, or like incremental operations. Like maybe we could do that over time, but it was just supposed to be really, we just wanted a simple file to describe your cluster, and then you just run up and it just deploys it.
And another question was what are the minimum requirements in terms of instances or machines to get a Rancher managed cluster running? The example, say, for a simple web app with database and proxy running in HA would be immensely helpful. So what are the kind of requirements?
I mean, so the size of the nodes, this is all, this is still just Kubernetes, so it's kind of dictated by what are the requirements for Kubernetes. The only limitation we have at the moment is that the worker nodes and the control plane has to be separate. We will remove that, I mean, probably within like a week's time, so that the smallest deployment could just be a single machine. So you're looking at like a single 1 or 2 gigabyte VM would probably be your smallest deployment. And then when you get in, then at how large you go is then depends on how big your cluster is. So I mean, there's we have three different roles for the host. There's control plane, etcd, and worker. The most common configuration is to put control plane and etcd on the same nodes and then run three of those. So for a good production HA setup, you're looking at 3 nodes for the control plane. Like typically, I mean, like a 2 gigabyte VM is typically good enough for not a super busy cluster. Like that will support, you know, probably like 50 nodes or less. So that's kind of the minimum for a good HA setup. For non-HA, it would just be a single node. I will tell you, this is one of the advantages of actually running like GKE or Amazon, or actually I'm not sure about Amazon, but Azure and GKE, both of those, the control plane stuff is free. You don't have to worry about that. They run the control plane for you, so you just have to pay for the nodes. When you're running Kubernetes yourself, like through RKE, you have to pay for the control plane nodes. And an HA setup requires 3 because etcd is a quorum-based system.
Okay, guys, there's probably another 20 questions, Darren, and I appreciate it.
Yeah,
let's jump into the demo. Maybe some of the demo will answer some of the questions, and I'll try to respond to some on in the chat window. So
yeah, I feel like we'll probably have a million questions. So let me demo it, and then we can come back to the questions. We'll see if maybe some of the demo will. Okay, so first, where to get this? So this is on, and if you just go to our GitHub page, Rancher RKE, releases 007 is like the latest dev. So just kind of give you the kind of expectation of quality and whatnot is right now this is still beta. It works fairly well. I mean, so the thing is it gets a Kubernetes system up and running. So once Kubernetes is running and it's the same deployment, then it's just Kubernetes. So like this does a good job. So it's actually in a very good state right now. I would say it's probably not going to GA until Rancher 2.0 GAs, but I just kind of give you the idea is this actually does a good job right now. It's not like total beta, it's setting up a good secure deployment. We're using X509 certificates and everything's using SSL, and so it's in a decent shape. But we're still calling it beta because this is our first release, and we're still actively adding features, addressing some little bugs. But anyway, so to download it, we have Mac and Linux binaries available. Just download those, set them to executable. So that's it. It's just a single binary. So when you run RKE, you'll see it's very simple. There's up, there's remove, and then there's config. And so config just kind of helps you bootstrap to get your original, like your first config file. You can go through and you can read the documentation. You can go through and read the documentation on how to create these files, whatever. I think the simplest approach is really just to use the command line to kind of bootstrap and get your initial YAML file, and then from there you'll most likely just manage it with editing it in a text editor. So to give you an idea, so there's different arguments on config. What I can do is just say, okay, just give me an empty configuration and print it out. And this kind of gives you the boilerplate of, these are all the various options that are available. You can go through these options. Basically, you have your nodes. Your nodes are going to have the address is what's the host name or IP that we're going to SSH into to manage the node. The internal address is what's the address that's going to be used with the internal communication of the nodes. We follow this approach. Sorry, I believe I think it was CubeSpray did this approach, and we really liked it. That they set up a local Nginx instance on every kubelet, and then you talk to the local one, which then will load balance to the worker nodes. I'm sorry, not the worker, the control plane nodes. So the control plane nodes, if one of those goes down, all of the kubelets have a local load balancer, so they'll automatically load balance. So you don't have to worry about, for the in-cluster communication, you don't have to worry about setting up a load balancer. For external communication, you still probably want to put a load balancer in front of your control plane nodes, but for internal, we don't need it. And so that's internal address is used for that communication. There's the role. The role can either be control plane, etcd, or worker. And that's, control plane is basically that's where we're going to put the controller master, the scheduler, and the API server. And then we set it up with the taints and so that it's known as a worker or it's known as the master node within Kubernetes. And I'll show you that as actually deploy one. Hostname override, this is a kubelet parameter. It's exactly the same as the hostname override on the kubelet. And that's basically if you want to control what's the host name that gets published to Kubernetes. That host name must be resolvable through DNS. It's how Kubernetes does exec and logs and some of the internal communication is it'll look up that. But actually, I might be slightly wrong in that because I think we do the resolution of internal IP, external IP, and then host name. But anyways, that's what the host name that gets reported. These other two parameters is we have user. This is the SSH user we're gonna communicate to the host with, and then the Docker socket, which by default is a var run Docker sock. But if you happen to have a custom Docker setup or it's not at that location, then you just change that. Then for each service, it's basically the same. It's pretty much the same of what's the image that we're gonna run. If there's any extra arguments you want to pass to etcd or the different Kubernetes components. And then some of the common configuration that we know we have to set are put as top level. So like the cluster seeder, the cluster, or the service IP range, some of these other things, DNS, infra, container. Okay, so that's, and then down here we have basically networking auth configuration. Auth right now, all we support is X509, which is basically, we issue a client certificate so that you can get one user, and then we issue certificates for all of the each component has its own certificate. So it's like the kubelet, kube proxy. Each one of those has a separate certificate, so we can have a different role. And then with RBAC, you can then limit it to the roles that are only needed, like the permissions that are only needed for each component. Networking right now, we have Flannel and Calico. And I think we'll be adding Canal, which Canal is kind of a combination of Flannel and Calico. It's Flannel for the lower level, like the VXLAN communication, but then using Calico Policy Manager for networking, for the network policy. And these last two arguments here, add-ons. Add-ons is you just put the Kubernetes YAML of what you want to deploy after the fact. SSH key path is the key that we're going to use to log in. So if you just go and run config by itself, it then gives you kind of an interactive way to set up this. So I'm going to run through this once to create like the basic one, and then we'll run that. We'll get the Kubernetes cluster up and running, and kind of add and remove some nodes. Just show you how it works. So here I'm just going to do 2 nodes right now. And I'm actually just going to put in kind of dummy host names because I'm going to go and edit this. I've already pre-spun up a bunch of hosts, so I have their IP addresses. But so we're going to start. We're going to say, okay, there's the first host is going to be the control plane. The user that I'm going to log in is just with root. Ask you, do you want this to be a control host? Yes. Do you want it to be a worker? No. Right now, don't combine those 2 things. We'll quickly address that within like the next week. Do you want this to be etcd? No. Oh, yes, sorry. Yes, I want it to be etcd. So I'm going to put etcd and control plane on the same. Like that's the most common configuration that we see. Do you want to override the host name? No, I don't need to set any of those. Use the Docker sock. Okay, and now I'm going to set up a worker. So the worker, use root. Is it a control plane? No. Is it a worker? Yes. Is it etcd? No. Don't need to override or set the internal. Use the default. So that's ask me what networking. I'm going to do Flannel. What security? We only have one option right now, which is X509. And then what are the Docker images? So right now we're just going to use etcd latest. And then for the Kubernetes Docker image, we're using Kubernetes. This is our official distribution of Kubernetes. I have to double check on this, but I'm pretty sure there's really nothing like special in that image except for the fact that it just has Kubernetes, because I know when we originally were doing the development, we were just using a Hypercube image. But right now, I mean, when you're getting RKE, you're getting a kind of certified distribution from Rancher, and so that's the image for it. What's the domain you want to use, the cluster IP ranges, and then final, what's the pause image you want to use. So after running all that, that's going to give me my basic cluster, this file. So if I go through here, I can kind of just clean this up a little bit, drop some of the default values we don't need. So you can see. So what I'm going to do, so now that I have like kind of the basic one, let me go through and actually put like real IPs in. And so what we're going to do, let's set up 3 control plane nodes, and then we can do like, I'll just do like 3 worker nodes. So I have those 3 control plane, and then 3, oops, did I do 4? 3 worker nodes. Okay, and then I just need to put in some IP addresses here. Okay, that's the first one, second one. Okay, so those are going to be the 3 nodes that will run the control plane, and I'm putting etcd on there too. And then I'll set up 3 workers. And the very last one. Okay, so this is my full file. So this should be 6 nodes in total. So we can run. So once you have that file, cluster.yaml, just keep it in your local directory, then run RKE up. And if everything's good, hopefully this works, we should get a cluster in a couple of minutes. So you can see here from the output, like typically what takes the longest amount of time is pulling the images. I did pre-pull the images on the hosts, so hopefully you know, it doesn't take very long. I did this. I just ran right before the demo. With the images pre-pulled, I set up a 10-node cluster, and it took 3 minutes. So this hopefully should take like 2 minutes at the most. But just kind of give you an idea of what this is doing. At the very beginning, you can see it's starting. It creates SSH tunnels to all those hosts so we can talk to Docker. We go through and we generate all of the certificates that we need. Then we deploy all the certificates to all the nodes. Then we start building up the different things. So we start with etcd, we build up etcd, make sure all the etcd hosts are up and running. Right now we are using a static configuration of etcd. So that's why like we can't add or remove an etcd node at the moment. We will enhance that, but it is like a static bootstrap of the node. So then we bring up the control plane, and then we start. So I think it's almost done. So then basically it's just going through and starting all the various components on all the different hosts or whatever. Then at the very end, we basically, once everything is good, I think at this point the cluster is actually up. We save all the information into Kubernetes. So all of the certificates that we have generated that are being used, they all get saved as a Kubernetes secret. And then any, like the cluster YAML file, we end up saving into the cluster state. So we always keep a copy of it. This is just in case if it gets lost or whatever. So typically you would hold on to this cluster YAML file, but if you were to lose or whatever, it is backed up into the cluster. So at this point, you can see it ran, it deployed the network plugin. We got kubedns. I didn't put any add-ons, so I didn't run any add-ons. So basically, we should have a running cluster at this point. So I'm going to show you, okay, it creates this file, kubeconfig cluster. This is going to be your kubeconfig. So this is going to be my kube config. I'm just going to set it to an environment variable so that kubectl will always read it. Okay, so everything's good. And we should say, okay, kubectl. So now we've got so the 6 nodes that are in there. So this Kubernetes, it's up and running. So I can do something like kube system get all. This is the flannel kube DNS that was deployed. Those different add-ons. So now the system's up and running at this point. What we give you when we spin up Kubernetes is it's a very bare bones. I mean, it's basically you get Kubernetes, you get kube DNS, networking, and then the simple X509 authentication. And then at this point now you can just deploy whatever it is that you want to do beyond that. We register all of the nodes into Kubernetes. So if it's a control plane node, it is still in Kubernetes. We're running the kubelet there, but they are set up with the taints and roles so that it's known as a master node and nothing will get scheduled there. But there is some advantages of having the kubelet on the control plane nodes because you can deploy control plane components with Kubernetes that run within the control plane. So let's see. I think so. What I wanted to, so basically, let me kind of show you now of so basically, now that we have this, we can, if we want, we can go and add a host. So if I just wanted to add another worker, let's see, just copy and paste this. Oops. Get another 174. So let's get another IP here. So then go and so this just adds another. So I just add another line in there. So if I run RKE up, so this will end up deploying another host. And so this basically, when you do up, it's like up is reconcile. So it is going to go through and kind of ensure that everything matches the file. So when you do an up, it's kind of like doing it. It's not redeploying the components, but it's going to ensure that all the components are in the right state. So the up will still take like maybe a minute, even though everything's already deployed. So when this is done, it should end up be running adding that one host. Let me. I wanted to show you. So I'm going to spin up Rancher, the tech preview one. Let me just launch this. So I'll show you once you have basically this RKE cluster, you can then just import it into Kubernetes, and you can see that.
And Darren, in 2.0, you'll be able to just spin up RKE directly from the Rancher UI.
Yeah.
Correct?
So then after I show this, I'm going to show this with Tech Preview 1, and then we're going to show you kind of what's coming in Tech Preview 2, and I'll show you how RKE is actually is going to be integrated into Rancher. So at this point, so if I do get node, I add another node, so now there's 7 here. So I just wanted to show you real quickly, so because the idea is that RKE, it's very limited in scope. It just gives you a Kubernetes. It gives you a base distribution of Kubernetes. You can install some add-ons. And the whole idea is that just to get that bottom layer. It's a simple tool to give you that bottom layer. It does one thing. It does it well. Then once you have a cluster up and running with RKE or any cluster, I mean, but specifically for here, we'll have a cluster up and running with RKE. Now I can register it with like a cluster management system with Rancher, and then Rancher can then start adding on a lot more capabilities in terms of authentication, authorization, the workload management, catalog, all the other various things that we do. And so just kind of to give you the idea there, let's see if this deploys. Yeah. So this is Tech Preview 1, and in Tech Preview 1, we could run an embedded Kubernetes, or we can import one. So this to import a cluster into Rancher, you just running you just run this one kubectl command, and then it should import in. Let me make sure. There's a little. There's a get. Oh, it's still going. Oh no, I think it actually. Sorry, it might have actually. Oh yeah, sorry, imported. So yeah, so you can see here the now that I've imported this into, imported into Rancher, then we can start doing things through Rancher, like managing the authentication, giving people other users, hooking up into LDAP, and I'll demo a lot of the stuff that we're doing in just a little bit. So here I can go. Oh, it probably hasn't deployed yet. Let me see. System. Yeah, it's still deploying some of the components. But I can get to like dashboard and then start using Rancher to then like deploy, catalog entries and all that other stuff. Okay, so I think I will stop right there for. I just want to see if I can get dashboard. Oh, it's not up yet. Give it a second. It will. Oops. It will. Takes a little bit to deploy. Okay, but I can answer if there's any questions right now.
Oh my God, dude! I've got 50. I'm typing as fast. I apologize already. I'm probably 10 minutes behind on questions, so I'm trying to get through these quickly. Is there a specific version of Docker you need to have on the host?
Oh yeah. So
Chris asked about, can I run 1.12, or is 1.12 still required? Do I use anything special on that host? So maybe just talk about the host.
Yeah. So again, it's limited to whatever is available. Whatever Kubernetes is really supporting. So right now we're pretty much telling people to stick with Docker 1.12. If you run with 17.09, which I think is the latest stable, it will fail. So yeah, right now we're adding that into RKE, that it will validate the Docker version, so that right now it just actually fails because Docker or Kubernetes doesn't work with that Docker version, but we'll validate it and say, hey, this host is not the right Docker version. So right now, 1.12 is still your best bet.
Okay, and why is that? And when is the plan to support 17.06, or what the latest is?
Oh, this just has to do with kind of that's what's kind of officially supported by Kubernetes. I don't know if there's. Oh, okay. So Kubernetes right now, I guess the versions are 1.13 and 17.03 is what Kubernetes 1.8 supports. So those versions. So basically, as long as you're using the version that Kubernetes supports, RKE supports it too. So there's been Kubernetes has always been a little behind on adopting newer versions of Docker. What the direction right now, though, is Kubernetes will most likely start using Containerd, and then it will be tied more towards the releases of Containerd, not the releases of Docker. And Containerd is expected to be a little bit more of a static component. It's not as big a scope as Docker. So even if you're running because like when you install the new version of Docker, I think it's 17.10 or 11, 10 or 11, I can't remember. The latest one actually includes the new Containerd that Kubernetes can use directly. So when you're deploying the Docker version, you then have to know what the Containerd version is, and then Kubernetes cares only about the Containerd version. So Docker might put out a new release every month or 3 months, but that's different than the Containerd. So we're hoping that the support system, like kind of as Docker continues to move forward, that we don't end up in this situation where Kubernetes is always behind, because the releases of Docker are different than Containerd, and now we just care about the Containerd level. So it should get better over time. But anyways, right now, Docker 1.13 or 17.03.
So is there any plan to replace the run C component with Moby? There was a question that Julian asked before. You foresee switching to Moby at some point?
Right. So Moby's a project. That's a little nebulous. So it's like Moby is a project which encapsulates open source components around containers. It's really it's a lot of the open source stuff that's been done by kind of Docker Inc. And so the I'm trying to think because so Moby is most of the Moby stuff is around Docker, and then all of the stuff below Moby, like Containerd, Runc, those are actually CNCF or OCI projects. So Kubernetes does not at the moment really have a direct connection to Moby. I think maybe some of the Moby components that they're doing around Notary and libtrust and some of those things might end up being used in Kubernetes. But basically, so it's kind of very long-winded answer of like pretty much Kubernetes is not really interested a lot in Moby, more at the Containerd level, and Containerd is a CNCF project. And so we're looking very heavily at moving towards the Containerd route.
Okay, great. There's a question. I mean, there's so many of these. One was, could RKE be a replacement for Minikube for local testing? Imagine using something like it for local dev testing for an EDE build of an artifact intended to run in Kubernetes. Any scenario you could see like that?
We'd like. I mean, it's interesting. So the thing is the hardest thing about Minikube is not actually the Kubernetes part. It's managing a virtual machine. So RKE would work great to run as a virtual machine on your laptop. Frankly, I like it better than Minikube. Minikube runs something called LocalCube, which is like a little different variation of how Kubernetes is packaged. So it doesn't give you the individual components. So it's a little harder for me to debug because I know the components, but it's packaged differently. So frankly, I like running RKE on my desktop in a virtual machine. But what I was saying is actually the hardest part of Minikube is actually spinning up and managing the VM. So we don't have a solution. I mean, so basically, if you took RKE and you combined it with Docker for Mac, it's great.
Got it. Thanks. Hey, here's a question. Pierre just asked: Is there any? I mean, could Rancher 2.0 run on ARM-based solutions, just like a cluster of Raspberry Pis?
I'll be talking. I'll be talking a little bit about that as we go into talking about the new like the architectural changes we're doing Tech Preview 2. I mean, the short answer is yes, yeah.
Okay. So I'm gonna. I think there's still a little bit of just like people asking for clarification between the difference between RKE and Rancher 2.0 deploying Kubernetes. So RKE is a separate project. Rancher 2.0 is going to leverage Kubernetes RKE within it, but this just is we've just sort of split it out so that you can use it independent of Rancher 2.0, and we can extend it independent. And the whole point of Rancher 2.0 is it's you can use any Kubernetes with Rancher 2.0. It sits on top of Kubernetes and does everything with any standard Kubernetes deployment. We have RKE, which will be really easy to use, but there's no difference between if you use our RKE and that brings up your Kubernetes, or if you spin up using, say, Docker machine to run a bunch of VMs and create Kubernetes. There'll be a couple different ways to bring up your cluster directly in Rancher. Plus, you can directly provision these Amazon, Azure, Google type clusters, or you can just import. So you're gonna have a lot of different ways to get the Kubernetes kernel into your Rancher environment. And lots of them. Anywhere on premise in the cloud for different teams, you'll be able to set all the access policies. So, I know Darren's going to dive into a Rancher demo now, but I'll keep answering questions, and please bear with me. Like I said, we have an enormous crowd today of people, and there are so many questions. So I'm doing my best to keep up.
Yeah, and just to answer that, so one thing is when we did so Rancher 1.6 or our 1.x product is built on Docker. So the assumption is you need to have Docker, and we've never. It's like basically you install Docker and then we take over from there. And so Rancher 2.0 is kind of similar of like in not being built on Docker, we're now built on top of Kubernetes. So you need a Kubernetes. And so there's a lot of different ways to get the Kubernetes, but there are, and we think it'll become easier and easier over time to get Kubernetes such that, you don't have to really, come to Rancher just to get the bare bones Kubernetes. But that story is still not as simple as we'd like it. And so RKE fills a certain niche of getting Kubernetes up and running, and then Rancher 2.0 will then do everything after that of doing the whole cluster management, the workload management, bringing in monitoring and logging and catalog and all the various things we do.
Hey, Ananda asked a really good question, which was just, is there a place like Docs where I can learn about the entire sequence of events that are called when RKE up is executed? I don't know how much we've created Docs yet on RKE, if there's a separate set of them out there. I know the blog we posted had a lot of this information. I'm sure we'll kind of standardize it a bit more over the next couple weeks. But anything you know of?
There's quite a bit of information in the blogs. There is docs. I just don't know if they've been published to our docs site yet. I'm not 100% sure about that. They don't go into the complete detail of the nitty-gritty of exactly what's being run. So we can probably have the engineers write up kind of what's being done. I mean, at the end of the day, we copy certificates and we launch containers. It's pretty basic, but I think we can have maybe put together a deep dive on what's being done there.
So there's a couple questions about like air gap and what actually is deployed. I mean, Tony said, does RKE deployment download anything other than container images directly? If so, has proxy support been baked in?
So we so our model is we SSH in and we run Docker commands and we pull images. So that's it. We just pull images, and so the image, you can specify what the image is for everything. So I'm still sharing my screen, right?
Yep.
So every single service, all it's doing is just running whatever this image is. And so you can change this image name and put whatever proxy, foobar.io or whatever. So you can change it if you want to mirror it somewhere. If you don't want to mirror it, one of the things is the only images that we are running are the images that are listed here. So it's etcd, the Rancher image, and then we start needing the Google components. So what RKE needs is basically these two images, and then it's what Kubernetes needs after that, which is the pause container, the DNS, what's in DNS, and then what's in like Flannel. So actually, now that I say it, so this should all work well with RGAP, but now I'm a little concerned about Flannel. I have to, because I'm pretty sure the Flannel, those images, I don't know where the YAML is. I think it might be in the code. I'll put that as like, that's probably going to end up being a bug that the Flannel is not going to work with air gap to set up to go through a proxy. But we will definitely fix that if it's not already there. Air gap setups are extremely important for us. We have a lot of users and customers who do that. So if give it a shot. If it doesn't work in an air gap setup, then would be a pretty high priority bug for us. But I'll bring this up with our engineers right now because I'm concerned about the Flannel component, the networking add-ons that they might not work.
So when a couple people asked this, once I've got a cluster up, and Andreas asked it, and can I just add more hosts to it? How do I run this again to change the config of my cluster, the scale of it, the size of it? How would I do that?
Well, yeah. So adding a host is just adding another entry in here. So you just add a host. So you just need to put in the address there and then just run RKE up again. So I did that. I demoed that just a little back, and so it'll just add in the host. And then there's the opposite operation of removing too. Removing removing is only if you want to do a very graceful remove, like if you're going to do like kubectl cordon, or sorry, kubectl drain. Like you can manually run drain, and then you run RKE up, and we will remove the node, doing a cordon and delete, and then we'll actually delete everything off the host too. Clean up the environment and everything. We only use Kubernetes. The way it works with CNI and whatnot does require some host level directories. So we do touch some directories. I can show you. It's documented in our blog of what are the directories on the host that we actually touch. The cleanup. So when you do RKE remove, we go through and we delete all the containers that we deployed, plus we clean up these directories. Those are the ones we touch on the host. And that has to do with, this is the SSL stuff, etcd persistence, that's where etcd is stored, and this is used for networking. Okay.
Okay. Lots more questions, but I think it's time to keep moving. I'll try to keep responding and answer some of these as they come through.
Okay.
Do you want to keep jump over to the slides again?
Yeah. I'm trying to think. Okay, so we're about what, an hour in?
Yeah, at least, if not more. I think we're an hour and 15 minutes.
Okay.
Oh, by the way, if you don't know, we record these and post them to YouTube. So if you have to leave, don't stress. It'll all be up there.
Yeah. So far, what we've talked about is we've demoed RKE, kind of why we built that and how that's working. So the rest of this presentation, we're going to talk about what's coming. So what we've already released, we've released Tech Preview 1. So we kind of want to talk about what's coming in Tech Preview 2 when Rancher 2.0 will finally be released, and kind of how that's working. So Tech Preview 1 was released in September, and it was very, very focused on getting our cattle user experience working on Kubernetes. And so it's what we're kind of, the term that we're using is the workload management. The word workload is actually, we're adopting that from Kubernetes. Workload is their term, which is kind of a grouping of like daemon sets and stateful sets and replication controllers and whatnot. And so that's kind of, in Kubernetes world, that's kind of the way you just describe the various controllers and how you're running your applications. And so Tech Preview 1 was very much about moving our existing user experience that people have come to know as cattle and getting that working on Kubernetes, getting that working with Kubernetes concepts. Tech Preview 2, which is going to be coming out in December, and that's what I'm going to give you kind of a sneak preview of some of the things here, is really all about the cluster management side. And so the cluster management is basically deploying clusters, like this is integrating RKE or integrating GKE, EKS, AKS, all the various cloud services. So actually deploying Kubernetes or importing an existing one. And then the management of those clusters from a security perspective, authentication, authorization, and then some of the resource management stuff too. So what we'll have coming out in December, I mean, it's a little fuzzy on the exact date in December, but basically the December timeframe, we're going to be putting out Tech Preview 2, which will then include all a lot of the cluster management stuff. So when we go back to this picture, Tech Preview 1 was the top layer. Tech Preview 2 is about getting this middle layer. And so basically once we have those two things out, then in January we're going to start the beta program. So that's when we'll actually be releasing the actual betas of 2.0. At that point we should be pretty feature complete, have most of that done. So we'll be ironing out the bugs and everything, and then shooting for GA in March. So everything that we've done with the previews, we're putting these out there so we can get early feedback. People can tell us what they like, what they don't like. Tech Preview 1 was very well received, just got a lot of attention, everything. But unfortunately, with the previews, these are things that we're not saying actually go and manage your workloads and stuff with this. We know it's not complete. It's a preview. It's to kind of give you an idea of what we're doing. So really, once we hit the beta in January is when we'll be putting out something that is, hey, you can actually use this to run your applications and help us iron out the bugs so we can get it to production quality GA. For all of our 1.6 users, we care very much about all of our existing users. We will continue to support. We're promising we will support 1.6 all the way through 2018. We'll continue to support it really as long as we need to. We don't want to leave any users behind. And we're going to do our best to make sure that we can move people forward from 1.6 to 2.0. Okay, so this was the architecture of Tech Preview 1. I'm not going to go in detail about that. But so Tech Preview 1 was really, again, I was saying it's about the management side, Tech Preview 1 was all about the workload aspect. And so as we moved into programming all the functionality for the cluster management, the architecture has evolved quite a bit. And we've been really doing a lot of enhancements to the architecture because they're kind of two different components. When you look at the workload management, you're looking at a single cluster, deploying applications within a cluster, and that's kind of your scope. And so the workload component is actually something which resides within the cluster. But when we started looking at the cluster manager, this is a component which sits outside of the cluster. It needs to be able to reach in and look at the cluster, all your different clusters, but it can't impact like the availability of those clusters. And so we had to basically, modify the architecture quite a bit, to accommodate kind of this two separations or whatever. And so this is a very simple approach, like very simple diagram of how the architecture works. It's just basically we have this cluster manager sitting out here, which is the Rancher server. We've moved everything over to be running on etcd. So historically, Rancher has always run on MySQL. We've moved everything over to etcd. We can still continue to support MySQL if people want that. We're just kind of waiting to see the feedback. There are some really interesting things that we can do with etcd that actually kind of drive down the cost and stuff like that. So it becomes easier to deploy. But so we have the cluster manager running as its own component. And then we run this cluster agent within each cluster. And the cluster agent provides functionality to the cluster manager, but it's also where it's running the workload management stuff. If you're doing anything like you want, like the compose support we have, or you're going through RUI or RCLI to manage like your deployments and pods and stuff. So one of the major changes that we've done to the architecture between Tech Preview 1 and Tech Preview 2 is we've actually removed the Java component. Historically, we've always had this Java component within Rancher. It was the first piece of code that was ever written. It was kind of like a monolithic. Initially, it was kind of like a monolithic application. Over time, we've pulled more and more functionality out of that Java code and done it in Go microservices. And so in 2.0, it's gotten to the point that the role that we continue to pull out more and more code out of it. That we basically got to the point that we kind of bit the bullet, and now it's just 100% Go. So the interesting thing about that is this gives us a lot more flexibility in how we deploy things, because Rancher has always been a little bit too heavyweight to like run on your laptop. It works, but it's a Java. It was a Java server. It was taking up gigabytes of memory, whatever. And so now by moving everything over to Go is we have some really interesting deployment models we can now do. And one of those is we can do a super lightweight, very small installation that would work better with like Minikube on your laptop. So you can run Rancher and Minikube on your laptop, and it's not going to be consuming a bunch of resources, and so you can use that now from a development perspective. One of the other things is we can now support ARM. Well, I'm going to say get closer to supporting ARM, because from a company, I don't know if we're technically going to sell support on ARM, but the point is we now can actually very easily compile for ARM and deploy on it. There's still a bunch of technical issues in the ARM world around multi-arc images, that's still up and coming. So, but hopefully as that advances, but now it's going to be very easy to deploy Rancher on ARM, and so we really hope Raspberry Pis and stuff like that, we start seeing Rancher more in that world, which is just really kind of fun. So that's some of the architectural changes that we've made, and so I'm now going to go through and I'm going to demo some of the RBAC cluster management features. You can kind of see how we're structuring the cluster management and authentication, authorization, stuff like that. So this is a preview. I mean, this is just a sneak peek. A lot of this is, I mean, I'll be honest, it's some of these things are faked or whatnot. It's this is all what's going to be coming out in December, in a couple weeks. So let me switch over to. And this is all running, what I'm showing is all running on the kind of the new architecture. This is all 100% Go. This is actually running in Minikube on my laptop right now. So this is kind of the UI that we already had in Tech Preview 1. Changed slightly, but this is kind of what we had shown before. This is what we're calling kind of the workload. This is basically what you're seeing here is you have namespaces. These are replica sets or deployments or whatever the Kubernetes resources are. So that's kind of what we already showed in Tech Preview 1. So where this now gets interesting is now when we kind of move up to the cluster management level. So we have at the very top level, this is global. So this would be terrible if this doesn't work. Let me just double check something. Sorry, guys. About to check earlier if this is in fact still running. Yeah. Okay.
There were a couple questions about how to ask more questions when you're off this. If you haven't already, the Rancher Slack is a great resource for connecting with any of us. I'm on it quite often, so you can just hit me at SMW355. Darren is sometimes on there. Vince is often on there. Craig's often on there. A lot of the guys, Adrian, Sebastian. So come on in, just start asking questions. Somebody will start to try to respond or get you in touch with the right person if you're trying to get it done. Again, there's so many questions. I'll try to kind of answer a couple while Darren is working this out. Mm-hmm. There's some questions about the different OSs you can run this stuff on. And we test on Red Hat, on RHEL, on CentOS, and on Ubuntu, and obviously on Rancher OS. But I know a lot of people run this on CoreOS. One person was just asking a question about Photon OS. They use it on today. So really, as long as it's a good version of Linux with the right version of Docker running on it, should work fine. The one we do sometimes see issues with is RHEL, so that's why we test quite a bit on RHEL, because it is sometimes a little more kind of different than other things. Ubuntu is recommended, to be honest. I mean, Rancher OS and Ubuntu are both what I would recommend you go use if you're trying to be on what the most popular things are. That's everyone. I would say probably 70% of our deployments are on Ubuntu. It definitely gets the most heavy testing in the community. So if you're just looking for something for production, you can't really go wrong with Ubuntu. You up and running, Darren?
Yeah, should be good. So
Okay.
as I said, I was
So
running on Minikube and just had to restart it real quick. Fun times with Minikube. Okay, so as I was saying, so what we were showing before was the workload UI. Now that all this UI, this is new, and this is basically. So now I'm switching to the kind of the global view. The global view is these are the very top level things. They don't exist within a cluster. So from a global view, this is really where you're going to be setting up like authentication, authorization, policy management, those type of things. And so at the very highest level, I have the clusters. And so I'll first go through. So in the ad cluster, we have three different approaches here. One is to import the existing cluster. That was already in Tech Preview 1. And now we're adding these two different approaches. One is to create a cloud cluster, and this is provisioning a host from, a Kubernetes deployment from a cloud provider. So this is getting it specifically from like GKE, EKS, AKS, those services. So we have a separate project which is probably poorly named. It's called Container Engine. I'll show you here. You can kind of run this today. What Container Engine is this is, again, a simple CLI, and it's basically the Docker machine equivalent for Kubernetes services. So Docker machine, you can go and just say like spin up a Docker host in Amazon. So Container Engine, it's specifically designed to say, okay, create a AKS or EKS or GKE cluster. Like it's specifically designed to hit cloud APIs to spin up the cloud-specific container services. And so we have this project that we just started. Right now, it only supports GKE and RKE, but we're adding Amazon was just announced yesterday, but we'll add that as soon as we get access to the API. But we're adding Amazon, Azure, and Bluemix. Or I think it's just IBM Cloud now. So going back to here, so basically this UI here is just basically using that project internally. Before in Rancher 1.6, we used Docker Machine to provision hosts. Now we're going to be using Container Engine to deploy full Kubernetes deployments. So then you can also deploy RKE, which is our own distribution of Kubernetes. And so here, what you can do is now this is then wrapping the command line in that YAML file, and we're managing this all for you. Basically, you can select what are the nodes. So you can say, okay, what nodes do I want to deploy? And so this is going to use Docker Machine. So if you already use Rancher in 1.6, we have two approaches to getting hosts. One is deploy through Docker Machine, or just run this custom command, this custom Docker command, which will register it with us. And so what you can do in the Tech Preview 2 is you can go and you can spin up nodes using Docker Machine or by running the command manually yourself. And that will register nodes with the cluster manager. So we kind of keep this pool of these nodes are available. It's like a resource pool of nodes. And so once you have these hosts, so if I go and I launch a host demo 2, that's going to go and basically spin up the host in the cloud, or take it. I mean, basically, it's taking it from this available pool of hosts, and it's going to spin up the RKE cluster. So here we can just say, okay, that's going to be management. These are worker nodes. We can customize this. We want X509, or we want Canal for our networking, and then just click create, and that will end up running RKE and deploying the clusters. So this is basically how RKE is going to integrate into Rancher. So you don't, when you do it through Rancher, we do it all graphically, and it's a nice user experience. And then additionally, we're bringing in the ability to provision the nodes because we can do that through Docker Machine. Okay, so once you have a cluster, so So yeah, so again, going back, so that we have these three approaches. The import the existing, we've kind of already showed a little bit. So those are the different approaches of basically how you get a cluster. Okay, so at the top level, I'm going through what are like kind of the high level concepts we have at a global level. Is we have the clusters, we have users. Users is basically once you hook up to LDAP or GitHub or whatever, it's what are the users available within your authentication system. Machines here, we might change the name of this. All the UX, we're still tweaking and fooling with, but machines, this is where I was saying before, like you have this pool of available nodes. If you're actually using Rancher to deploy Kubernetes and manage the Kubernetes deployments, then we have available nodes that you can assign to clusters or remove it from a cluster, or just see where your hosts are allocated to what clusters. Sorry. So then this is roles and PSPs, that's short for pod security policy. This is where we start getting into the authorization stuff. Sorry. So in order to manage authorization, we've introduced this concept of projects. The way authorization works in Kubernetes is you basically have authorization at two levels. You have cluster and namespace. So you can authorize things to a namespace. You can also authorize things to a cluster. One of the kind of complexities you run into is that, if somebody has to authorize things to a namespace, then you have to go and set up all those rules. And like because of the way it works in Kubernetes with like escalation, they make it so you can't escalate privileges and whatnot. It's a good feature. Basically, the only way to get a namespace is really you have to go to somebody else who has like the proper privileges, to then issue that namespace and then authorize you to what you can do. So a lot of times when people are using RBAC, it's kind of like you go to a central team or something and say, okay, give me a namespace. They create a namespace, they authorize whatever you need, and then you can use it. For us, we wanted to make the kind of namespaces a lot more self-service. It's easier to because namespaces become really important if you're deploying a lot of applications. Like, let's say I'm doing a CI/CD workflow. If I want to deploy the same application 3 times, I really need 3 namespaces. Otherwise, they're going to conflict with the label selectors and all those other things. So the creation of a namespace needs to be like more self-service. So we introduced this concept of a project. So we have a project. In a project, we can then associate all the rules, all the things. So I can go, for a project, I can go and create a role and say, okay, this guy is, I have a role here of like, okay, you're allowed to delete pods. So I say delete and select the pod resource. You can add as many roles as you want, rules as you want, and you can also aggregate other roles. So you can say that the delete pod, whoever's allowed to delete, is also able to read. And you can go and create these rules. Resources required. Oh, oops. So you can go and create these roles, and then you can assign the roles to projects. So I'll show the project management in just a second. So basically, the roles is managed at a global level. So what roles are available is that's kind of most likely is going to be set up by a more administrative person. They define all the roles. We'll have a series of built-in roles that will probably cover most use cases. We don't really see that people are going to have to create a lot of crazy custom roles, but it is there. All the flexibility is there. Like, we're going to try to cover most of the basic use cases with built-in roles that we'll have. So at the global level, you're defining the roles, and then there's also Kubernetes has this thing called pod security policy, which then controls, this is a more fine grain of containers, of like if they can use host networking, if they can use the host PID namespace, if it can be privileged, whether or not they have to have a root file system, what volume drivers they're allowed to use, like if they can bind mount host directories, what directories are they allowed, like a whitelist. So there's various things. So this controls a lot of the security around the containers. So you can say, I have this pod security policy where, they're not allowed to do anything privileged. or I can have one where they're allowed to do things privileged, and then you're going to grant those or authorize those to users. But so the management of the policies and the roles is done at a global level. Now, once I get into a cluster, I'll go back to the dashboard in just a second. But once we get to now I'm dropping into a specific cluster. I have a cluster called local. So here within the cluster, I can go and create projects. So the project is where you actually, now once I've had all the roles defined at a global level, I can now add users. So I can add Darren, I can add myself, or whoever can add a user to this project, and then they can give them this role. So now that user has specific authorizations within that project to do things. So once the user is in the project, they can go and create namespaces. And then what we do is we automatically then populate the namespaces with all the authorization rules and everything. So a user can go and add and create and delete namespaces as they need to, because the namespaces are associated to a project. So if I go here, you can see, oh, here's all the various namespaces I have and what project they're associated to. So what we've done with Rancher is we've taken the Kubernetes authorization concepts and just moved it up one level, because the raw policies, like Kubernetes has a very good authorization system to enforce all the authorization that, like RBAC, that I need. It just gets very tricky around the management of things where it's like, I want to be able to have a user who can then, set up and assign other users to do things, but that person does not actually have to have those same level of privileges. There's all these different different scenarios of varying privileges and delegated privileges or whatnot that are hard to accomplish directly with the roles that they have. But we can do those all from a higher level through the projects, this concept of projects, in which then get propagated down to Kubernetes. So at the end of the day, all of the enforcement of authorization is all done by Kubernetes, but we're managing it kind of at a higher level that, we think the model that we've done aligns much more of how you're going to manage things within an organization. Right. So as I was showing before, so this is the global level. The global level has basically like the authentication, authorization clusters, and then once you drop into the cluster, we have basically kind of the dashboard now. It gives you an overview of what's being used, some of the component status stuff of like etcd is good, management servers bad, or maybe one of your nodes is bad. And then you can see the individual nodes, kind of what's going on with the individual nodes, if there's it's in a bad state or whatnot. Networking and storage, we're still doing these, but this is to manage like the storage classes and network policies and those things for the cluster.
Darren, there were a ton of questions about storage, and by the way, if you've asked a question a while ago and I haven't answered it, it's probably because I want to ask it publicly or have Darren try to address it. So don't get too frustrated. It takes a while to get your question answered. But there was a question from from Pierre, saying we support some storage abstraction other than NFS, for example, Storage OS, and then the new asked if you could demo adding volumes. Do you want to just talk about storage in Rancher 2.9?
Yeah, I mean, well, one of the great things was, so the storage that we had in Rancher 1.6 was we ended up having to build a lot of the storage stuff ourselves. So the nice thing about moving over to Kubernetes is we get to leverage what's in Kubernetes, and so there's already support for a good amount of the storage, storage systems that are already out there, like Storage OS that's already natively supported in Kubernetes, I believe. So our storage, when we talk about, whatever's available in Kubernetes is going to be available in Rancher 2.0. From kind of the workload management, our UI perspective, we're going to make it a little easier to manage storage, just put a better user experience on it. But under the hood, it's still going to be persistent volumes and persistent volumes claims and storage classes. Some of those concepts are like have a little bit of a learning curve, and that's why we're ending up putting kind of a different approach, so people can understand it a little better. But it's going to be whatever the drivers are that are available within Kubernetes, which is quite a bit. At this point, I mean, most popular, like I'm not actually aware of like a something that's mainstream or even like some of the newer like Rook or something like that that's not supported in Kubernetes. Um,
There was a question
we
actually.
don't we
Oh,
I would say
sorry.
all the volume stuff is going to be in the tech preview too. I don't have I don't have a I can't show it here right now.
Okay. I did want to say, so there was a question about Convoy from, sorry, I just responded too quick to even see the name, but there was a question about Convoy, and I was wondering, is there any plan to keep pushing Convoy forward into Rancher 2.0 and support some of that, kind of simple hooks and backups, things like that for the storage volumes?
Not for no Convoy for the most part. Has been kind of sucked up into like the functionality of what we were doing there has kind of been kind of sucked up into the Kubernetes world. And so there's a different standard going on right now, CSI. So we're more interested in supporting that going forward for the kind of the storage stuff. And I think as part of CSI, they're trying to address snapshot and backup. And so that's like always been like the big problem or the kind of the big gap in the storage management of container stuff. And so we're kind of following along with that, looking at it. I mean, EMC is doing a lot with CSI, and we work with them a lot, and so that's what kind of where we're looking forward. Convoy itself, we won't. I don't think we plan on continuing to support that. We have a different project, Longhorn, which is a distributed storage system. We are continuing to develop that. Hopefully, we'll have some pretty cool announcements around that beginning of next year. But yeah, so that's kind of the story there.
Cool. So, was there anything else you wanted to demo? Otherwise, I've got another 15 questions or so that are kind of all over the place. But
no, I think that's most of what we just wanted to do with it. Just kind of give you an idea of where we're going with the tech preview 2. This is just a sneak peek. This stuff will all be coming out in December. Have all the cluster management. A lot of this will be more fully flushed out and to get this fully managed. But the big thing you're going to see in Tech Preview 2 is all of the authentication and authorization and all that management. Yeah. So I think that's pretty much it that I have for the demo of the Tech Preview 2.
Okay. Awesome. Let me just throw some questions at you. Feel free to start firing away questions for Darren or anything else you want to ask. We'll try to get through these. I'm going to kind of roll back to some questions that came in, some like almost an hour ago. So if you're still on, Alwyn, Mark, I appreciate you being patient. You were asking about what are the file system requirements if I want to run a small HA setups of databases? So do I need network storage, or is there a way to use tools like Convoy to let Kubernetes move state like described in some examples of running WordPress and such? So, if users are setting up some basic storage, or what would you recommend as a getting started point?
So I mean, if you're looking at running, if you're looking at running persistent systems in Kubernetes, you should be looking at stateful sets, which is a very conservative approach on how to do orchestration for kind of more pet-like systems. From a storage perspective, it's really just dictates. It's like the container system is not going to, as long as you're using a volume, you're not running it off of the root of the container, because that's going to be an overlay file system and it's going to be slower. As long as you're running a volume, the containers don't really add any distinguishable overhead, and so it depends on what's the backing storage for that. So most of the time, what you see people doing if you're running a database is you use a storage driver, which is going to give you persistent volumes from like the cloud. So like an EBS driver. So you actually run the database on EBS, and then you run two server, like two pair, like a master and a slave, or doing database replication. So typically they're running with some persistent storage from the cloud. I definitely wouldn't run over like NFS if you're running a database application.
Okay. This is sort of a 1.6 question, but is there any update on when 1.6.11 is coming out? There was a couple different people that said they had seen different dates for this, and they were looking forward to some support. So, any ideas on your side? Maybe Denise, I know you're on the bridge. If you know the
Well,
answer,
so I believe it's released already, but we have a basically what we do is we release something. Um, we release it, and then we don't mark it as stable until it's gone through a certain bake-in period. So that was 16 days ago. So I think I don't know. I don't know if Denise is on. What's the story?
All right, I'll post this forward. Maybe Denise can just respond. I'll respond to her note.
Oh, so I guess okay. So there's going to be, I guess, a 1.6.12 that will end up being marked as stable. And it should be today or tomorrow. I guess there was an IPsec memory leak in 1.6.11 that they're addressing. So yeah, so we're looking at today or tomorrow. And then I guess there's some random Kubernetes issues, but yeah, so very very soon, and so that'll be 1.6.12.
Okay. There was a question that Gutet asked, and he said, "Is there going to be a way in Rancher to run like a cron job on containers,
Yes.
sort of like cron?" Do you want to talk about that?
Well, so this is just a kind of a native feature of Kubernetes, and it will be exposed through Rancher and our UI and everything. Basically, when you deploy a container, you can just say run it on this interval. So the cron, you can set up a cron schedule of when to run the pod or the container, and so that is coming in 2.0.
Okay. So there's a question Troy asked. He says, "Are we doing it?" He said, "Will there be any better support for when WebSockets fail to connect?" Not really sure what the context is for that, but if you want to respond, maybe I can ask him to clarify.
I mean, the architecture's changing, whatnot, and so, I mean, there's a couple. Yeah, I don't know. That's a hard one to answer. So there's two WebSockets connections. One is the UI, it's making a WebSocket connection, and then the nodes make a WebSocket connection to the Rancher server. If you lose that WebSocket connection from the node to the Rancher server, then you can have issues like if that connection can't be restored. That's changing in the architecture because that connection has a different role of being a little more advisory, like things still work fine without it. But the connection from the UI doesn't really change. We're going to give a shot at using Kubernetes or Amazon's ALBs again. Like the history there is like we need WebSockets to work. ELB doesn't support WebSockets, so we have to go through all these hoops with proxy protocol, and it gets super complicated to set up, and a lot of people don't do it right, and so it's a big support issue for us. We tried to use ALB. ALB was very flaky for us, but I'm hoping we're going to give it a shot again that ALB works better. If ALB works better, then a lot of the woes you see around WebSockets in Amazon goes away.
Cool. Desmond asked a question about RKE a while ago, and he asked if it required the user to use the Rancher 2 image, or can vanilla Kubernetes images be used? I'm not sure. I didn't know how to answer that. Do you?
I have to double check on that. So I was saying because you might be able to just use the Hypercube image and not use the Rancher one. I think that might be possible. I have to double check with the engineers if we're doing anything special. I would like that to work. If it's not, then if it doesn't work, then we'll see if we can support that. I don't see any reason why not. So it should be good. So so we want to be able to let the user change that. So the main reason that it's a Rancher image is the fact that you're getting what is our actual certified Kubernetes distribution. Certified both by us and by it's a CNCF certified distribution.
Awesome. And I just posted that out, Mohammed or Hussein, if you're on and you want to kind of respond. There's some of the engineers who worked on it. I'll retweet your or respond to your answer. Um, there was a question from Samuel. He said, "Is there a way to configure port range management? Today, I can't open a range of 5,000 ports, for a media server, for example. Do you know anything about that, Darren?"
Yeah, it's not getting any better. So basically, like the backstory there, Docker has supported port ranges, but the way they supported it is quite bad. Like if you do 60,000 of them, they end up creating like 60,000 individual entries in their kind of memory store, so it doesn't really scale well and it causes a lot of problems. So because of that, we've never supported Docker. We never supported rangers. Now, as we move to Kubernetes, it's the same story there. They also do not support ranges. So unfortunately, that's right now we still don't have a solution. If you want to open up a large range, it's typically we're telling people of, use host networking. So you're just exposing the application directly on an IP. Yeah.
Okay, cool. It said, can RKE run something like failover cluster? I configure a provider like AWS. When one agent is not available, I guess it creates a new server, install Rancher, and run containers on it. Do you need...
Right. So the way RKE works is it's going to set up, like, let's say, like, I have 10 nodes. It goes and it deploys Kubernetes on those 10 nodes. If one of those nodes goes down, Kubernetes will stay available. It will still work, but you've lost that node. RKE will not recover and bring in that node. We're expecting that to be done at a different layer. And so that's a functionality that we would see either being accomplished through using like Amazon auto-scaling groups or using features that we would build into like the Rancher management product. But like the actual dynamic recovery of losing a host is not within kind of the scope of RKE.
Here's a question. Oh, this was Boris. He just asked about the API in Rancher 2. Will it be similar to the 1.6 API?
Right now it is quite different, and we will be looking at building basically support for the older APIs on the new APIs. So this is, this is kind of all part of the upgrade strategy and how we're going to move users from 1.6 to the newer one. So exactly how that's going to be done is still a little bit up in the air as we, more solidify 2.0. So as 2.0 gets closer to shipping, then we're going to more heavily look at the upgrade strategy. So, what we've discussed is supporting the V2 beta is actually in 1.6. We've always had this V2 beta API, which is actually our primary API. But we never actually removed the beta tag from it. It's actually removed the beta tag because that is actually the primary supported API in 1.6, and then supporting that V2 API in Rancher 2.0, which is actually using the V3 API.
There was a question from Remy on that same topic. He said, did you ever do the cleanup around the environment/project misunderstanding inside the API?
Yeah, well, yeah, so ironically, we moved, it's now called project in the UI. So it's still project in the API, but it's also called project. So one of the things that actually has changed from Tech Preview 1 to 2 is in Tech Preview 1, what we called an environment mapped directly to a namespace. As we started looking at authorization in RBAC and stuff like that, we figured out that mapping didn't work well. So a namespace in Kubernetes is a namespace in Rancher. And then what used to be called an environment is now a project. So a project, we switched it from environment to project. Hopefully we don't change the name again. But we didn't feel like the term environment was really indicated what it was, and project was a better term for it. which ironically goes back to what it was called in the API originally, because that was the original vision of what an environment was it was more of a project concept, which is an arbitrary grouping of resources. It's the thing I collaborate on, thing I assign privileges to. Yeah. So yeah, we've had a fun history with that.
Nicole asked if the OpenStack cloud provider would be supported, or is supported, or will it be added?
I believe we have OpenStack today.
You mean as a cloud provider support in RKE, or in?
Okay. So what we do with RKE is RKE actually by default ships with no cloud provider. The cloud provider option is just off, so you're actually not going to get a service load balancer by default. But we don't do anything that like prevents you from using a cloud provider. So in the cluster YAML, there's a section for extra args, and you just have to put in there cloud provider equals OpenStack, and then you can use the OpenStack cloud provider, and it should work. I know we haven't tested OpenStack. We typically look at Amazon, and then I think we support Azure these days. But within RKE, you should be able to get OpenStack because we're just basically trying to give you a vanilla Kubernetes, and so the only one thing that we end up with, things being a little different is that the kubelet is containerized, so storage drivers storage drivers have some issues, but cloud providers and network drivers should be all just off the shelf, just work.
Cool. There's another question. Will Rancher 2.0 support spinning up a cluster on vSphere? Will there be support for OVAs/templates or only ISOs?
Oh, I don't know if that. So it will support spinning up through the vSphere Docker machine driver we have today, but I'm not super familiar with what are the parameters. But their support for vSphere is going to be one of two things. It's either going to be you already spun up the host and you just give us the IP address and then we'll provision Kubernetes on it, or we use the Docker machine driver. So it's really what's available in the Docker machine driver.
Awesome. Why don't we? I know we had a couple more slides we wanted to kind of wrap up, and then there's a few more questions that we will answer before we leave. But I'm going to just jump back into being the presenter, and hopefully you guys can see my screen. I'm just going to slide through this stuff, and just kind of to wrap up, if you haven't already and you want to just get started with the tech preview, you can get started really easily. Just create a Linux host anywhere. We need sort of a reasonably new version of Linux OS. Make sure it's got a decent amount of memory on the host, and then just start the server. And you start Rancher, just running Docker run Rancher/server. But for the tech preview stuff, just do :preview. I think we run out preview 2. I think that'll just upgrade to the newest version. So get started. It'll set up the server, and you can play with it, try out 2. Love your feedback. Like I said, we're really taking into consideration a lot of things are even changing between preview and 2 based on feedback from users. So that was awesome. The other thing is I sort of joked about it on the Slack, but the whole project is open source. So even the docs are open source. So please, if we have a great quick start guide. You can find it at docs/v2.0, and then the quick start guide down there. You see the link. I'll post all these slides, but the big thing is, if you see something and think it'd be better, help us out. We'd love to get more and more people involved. We have some great people in the community that help enormously on Slack and help in the projects, but we'd really love more. I think in a lot of the project is getting easier and easier to participate in. We've had a lot of people start providing bug fixes and such. So if you're interested, get involved. The projects are all open, and they're all up on GitHub. You can really see everything that's going on in them. With that, I'll sort of wrap up this section. We'll keep going with questions, obviously until they're all done. But for all of you that are here, thank you so much for attending today. It's awesome to see hundreds and hundreds of people coming on to kind of talk about this stuff. Okay, Darren, last couple questions. This one was from Gutet. He said, will Rancher 2.0 be compatible with two-factor auth, especially U2F? Any idea?
Mm, I'm not totally
Anything?
sure about that. I mean, we, so we plug into like GitHub, LDAP, and
AD?
AD. So it's all based off of those systems. So I don't know, like if you're using GitHub, if like we have, I don't think we don't have any specific issues with two-factor auth, because we use. I mean, I have that turned on in GitHub. Um,
I know for a lot of our enterprise users, they
Oh,
do this.
so for our own local implementation, so we've had like local auth. Right now, uh, we don't have any plans right now of like adding like two-factor to our local. I mean, honestly, most of our um, users, like our enterprise users, are using like AD, LDAP, those type of things. Um, so if there's interest, just put in an issue, and um, if we get more people interested, then we can look into doing that. We are moving to a model that one of the Rancher has always been when you first install it, there's no authentication on at all, and obviously that's not great from a security perspective. You have to actually like once you install it, you have to turn on authentication. We are going to move to a model where authentication is always on. It's always on and it's always SSL. So it's going to be basically kind of secure out of the box. Um,
Cool. Another question. This one was from Max. He said, regarding storage, what is the recommended solution to have several pods share some files? This question is for 1.6, but also for the future 2.0 version.
Yeah, I mean, typically that'd just be NFS. I mean, that's what works the best. I mean, I'm assuming when you say a series like sharing files, you mean across hosts, and so NFS is really the best way to go. And so we have good support for NFS and EFS, Amazon's like specific implementation of NFS. So that's really what I would recommend.
Awesome. There's another question from Alwyn. He said, this was kind of earlier, I think, when we were talking about the different database approaches, and would it be redundant to run a replication through the database application and also use sort of cloud storage, in the sense of if you wanted to replicate it SQL or something and then have cloud storage on the back end, in that it would put high pressure on the network and make the application less stable, unless you're maybe running an AWS. So I don't know. It's not really a question, just a comment. I'll just sort of forward it out to everyone else. There was another question that was, let me pull this one up here, that Patrick asked. He said, as I've understood in Tech Preview 2, you're moving from MySQL over to etcd as the database and from Java to Go, right? So setting up a small high availability cluster may be a bit easier now with the new technologies. Do you want to talk about that, Darren?
Yeah, so the idea is it should be easier. And we have a lot more options too because we have etcd. We still can support MySQL, but we're kind of hoping that most people just be happy with etcd. And so it should be a little easier to set up. And so we're actually going to bundle in. So like when you say like Docker run Rancher server today, like with 1.6, MySQL runs in there. And we'll do the same thing with etcd, so that we'll basically bundle in etcd. So when you run it, it's running etcd. And if you want to do an HA setup, it's going to be basically just run 3 Rancher server containers and configure the peer addresses, and then it should run a HA cluster. The only thing you just have to be careful of is keeping quorum. If you're running 3, don't shut down 2. But so we're going to try to make that as easy as possible, and really do a lot more to help the users out in terms of running etcd. So we'll always have the ability of like just give me an etcd, the credentials, and so you can just run your own. But we're going to take a little bit more responsibility and try to help people out. Like with MySQL, it's always just been, run an HA setup or get RDS or something like that, and we've kind of been hands off. But with as we move to etcd, we're going to, I guess, take a little bit more ownership there and try to make it even easier. Yeah.
Awesome. Last question, unless someone else throws one after this, but Remy just said, can we use HTTP port.us.org as Docker registry to store on fetch images that will be used. I'm not 100%. I don't know. I'm not familiar with that, so I don't know if you are, but I would throw it to you if you were.
No, I don't think. Sorry, what was the address?
It was port.us.org, like port.us.org. I'm not sure. Not familiar with it. I'll post it to the question.
Are you just saying Portis? I mean, so if you're talking about Portis, which is like is that SUSE? SUSE the ones who did Portis? We've always we have users who use it. We don't have any problems with it. So I mean, it's just one of the various many registry options out there, like Artifactory or Nexus or Quay or whatever. So Portis works. Yeah.
Okay.
I don't know.
Cool. Okay. Last thing was just someone asked do we have a release date for TP2 yet? We haven't set a date, Scott. It's just it'll be sometime in December. It's getting pretty close. So
yeah. So it's for the sake of our engineers, we would like it to be before Christmas, no holidays. So we're trying to get it out as soon as possible to not ruin our holidays.
All right, everyone. Thank you all. The hundreds of you who are still here after 2 hours. You guys are awesome. You're like warriors. And we'll be posting all of this up for recording now that everyone's told me how to save the questions. I'll try and figure out what the heck to do with them once I save them, and we'll get them out to you and put the slides up on SlideShare so you can pull them down and share them with other people if you'd like. The last thing is if you haven't already joined the Slack, we have this kind of conversation all day, every day there, and it's a really fun place to meet everyone else who's doing these things. So, Darren, thank you so much for spending so much time demoing and talking, and we'll be sending out obviously information about the next meetup in the next couple weeks once we set the timing for that. It'll probably be even more tech preview 2 stuff. So. If you have other ideas for things you'd like to do meetups on, don't hesitate to send them to us. I'm Shannon at rancher.com. Darren is Darren at rancher.com, and we're always love to hear from you guys. Okay, with that, I'll wrap it up. Thanks a lot, everyone. Have a wonderful, wonderful day.
All right.
Thanks, Darren.
Bye.